Hi everyone, my name is Vukašin and I'm a Cloud Solution Architect for Microsoft.
Hey everybody, my name is John Lunn, aka Johnny Chips, and I'm a technical architect and I work for BT Enterprise in the UK.
My name is Ahmed Laja and I'm a Cloud Solution Architect at Microsoft.
Hi, I'm Anna McNally. I'm a Cloud Solution Architect at Microsoft.
Hi, my name is George Washira. I work for the Intellectual Property Office as a Senior Engineer for the End User Services.
I'm Richard Griffiths and I'm the Cloud Solutions Architect at Confused.com.
Hi, I'm Abul Kaya. I work as a Technical Payment Specialist for Clearbank.
Well, there we go. Good evening, everybody, and welcome to the Welsh Azure user group on not the 18th of March, because it's now the 15th of April, and clearly I've not updated a slide, but hey ho, that was our Welsh Azure user group team. We're all obviously in the room. Well, most of us are, I think, at the moment. So we kind of do that just to kind of let you guys know who we are, you know, who you want to reach out to kind of try and nab a free t-shirt and things like that. And we say no, of course. And no, we won't. We'd probably say yes and then ask Des and Luke for some more money to buy some more. No. we'll see. Right, yeah, so obviously, you know, on a serious note, we're all here to set up these user group sessions, you know, to try and pull together some great technical content to put back out to the community and give you some more, you know, hopefully inspirational talks that you can crack on and do some more learning. So I'm going to get off this slide. It's got the wrong date on it. There we go. Right, what have we got lined up for today then? So 15th of April, thanks everybody for joining. If you joined us last month, we tried to do a virtual lightning talk session where we had sort of 6 or 7 lightning talks, sort of 15-minute sessions talking on a particular topic. We thought it was a really good idea as a group, so we thought we'd keep to the theme of hosting some lightning talks and then look to do, you know, like a little bit of a feature talk with a full-length 45-minute hour talk. So we've got Anirban is joining us. He's going to talk to us around Kubernetes in a bit. We got Vukašin joining us in a bit after Anirban. Is going to talk us through how to actually create Visio diagrams, which is pretty cool. Something I always struggle with as an architect, and don't lie, everybody. I know you all do too. We got our very own Matt Fortunka going to talk to us about the REST client and using Postman and VSCode. And then our feature talk for tonight, we got the wonderful Pete Gallagher and Liam Gulliver. Really cool talk. I mean, I've seen bits of this over the last 6 months or so. Really excited to see Pete and Liam walk through this solution using a robot arm and controlling it through Azure. It's all really cool and really interesting stuff. So, like I say, there's our agenda. They're rough timings. Hopefully, we'll stick to them or thereabouts. We decided to shake up the prizes tonight. Oh, you know, we know that this group has been such a generous group with the prizes, but we've had some merch. So, after all the talks, if you stick around, and please do stick around, we've got a quiz on the go. Download Kahoot and obviously join in on that quiz. We're gonna put 2 £25 Amazon vouchers. We're gonna keep 1 voucher for the first prize winner. The first prize winner will also get a hoodie, which a few of us are kind of wearing at the minute. Yeah, there we go. So we got a hoodie for first prize winner and a £25 voucher. Can't argue with that. Second prize, you're going to get yourself a t-shirt, a Welsh Azure user group t-shirt. And then what we're going to do is we're going to keep that other £25 voucher for if you stick around to the very end, last slide, take a shot of the feedback form and obviously give us some feedback and we'll pick a winner at random. We've also got some other bits and pieces. But before we jump in, housekeeping. Obviously, this is an open user group. You're all in control of your own microphones. Obviously, keep yourselves on mute where you can, not to disturb the speakers. Obviously, be courtesy to each other. You know, this is an open, positive forum for happy chat. There's no negativity. And if there is, I'll kick you out. You'll probably be able to join again, but I'll kick you out again. So don't, just be nice. No silly questions. Obviously, ask anything. We've got some really intelligent, educated, great people in this forum. So if you've got a very specific question, we've got the guys and girls from Microsoft on here. We can take it in any which way that we need to if you need specific answers. And obviously feel free to ask those questions. Like I say, if you can stick around to the end and leave us some feedback, we really do read the feedback because we want to try and angle these group and these sessions, especially when we get to the face-to-face as well. So we really want some feedback from everybody that joins them to let us know what we're doing right, what might be wrong, you know, sack the MC, all of that kind of stuff, no problem whatsoever. And finally, don't forget to install the Kahoot app because There's nothing worse than waiting for ages at the end. Okay, you can have another T-shirt and some stickers. Yeah, if there we are. Well done, Reese. See, Reese has got the stickers as well, Des. What are you doing? Tweet and win. It's a tweet and win. So what I want you to do is take a picture. Don't go running off now and get your favorite tech swag or whatever. Do it at an appropriate time, not in the speakers. In other words, do it at some point before tomorrow morning. Tweet and win. We just want to get the name of the group out there. Yeah, you'll help us spread the word. Give us a comedy photo. You know, I take nothing but comedy photos. What we'll do, we'll pick a winner at random for another T-shirt and some stickers, and obviously we'll get that, and we'll pick that tomorrow at some point. So tweet to Welsh at Welsh Azure and put the hashtag WAUG. I was going to try and say that as a word then, but it isn't a word. So yeah, there we go. So we got loads of prizes. We've got loads of good speakers. We've got loads of prizes. What more do you want from a user group, eh? You know, free beer and pizza would be good, but we'll have to wait for that, of course. Right, a note from our sponsors. So at this point, Mr. McDowell, over to you, sir.
Well, initially it's over to me, John, but I bring that's absolutely fine. Thanks, John. Hi, everyone. Good evening. For anybody who doesn't know me, I'm Des McGuire. I'm the founder and Azure Solutions Director at Servant. I've been in the Azure business for about 11 years. I've been involved in Project Red Dog in the early days. Not many people have or don't even know what that is. That was well before it was even Windows Azure. So we are an expert Azure partner based in Scotland, but we work all over the UK and beyond. We're also a proud sponsor of the Welsh Azure User Group, the Northern Azure User Group, and natively the Glasgow Azure User Group as well. So we love to give back to the community. We are trying to do more sessions, more customer success sessions this year, and that will include in the Welsh Azure User Group. Some of the projects we're working on that's keeping us busy, and we do Azure at true enterprise scale. So we've got about 20 data center migrations, and we're talking thousands, tens of thousands of VMs, including those migrations. We've also been doing a ton of WVD at scale as well. And the reason that Reese is here, so I'm going to introduce Reese McDowell from our side. He's our Azure Cloud Engineer. Reese has been involved in a enterprise scale project for 72,000 seat WVD deployment. And really, Reese has got a really good story in terms of how he came on board at Servant. So before I talk a little bit at the end, I just want Reese to introduce himself and tell you a little bit about his story, how he came to join Servant. You're on mute.
There we go. Thanks, Des. So as you said, Reese McDowell, Cloud Engineer, Servant. Getting into Azure was something that I've been trying to do for the past 2 years to try and really get into it. And of course, one of the first things I did was join these type of user groups. Of course, it was a Glasgow Azure user group that I joined. Just getting in and getting involved with the community, I've seen that Servant, of course, are the sponsor of these user groups, and they had an ad at the end of the user group meeting. It was Servant are now hiring, looking for X, Y, and Z. So I thought, you know what? I've been trying to study this. I'm trying to get my certifications. I'll reach out and see what would happen. I sent away my email. I ended up finding Des on LinkedIn and sending him a message. Des apparently liked what he seen and brought me on board. And at that point, I really ramped up, coming from a Windows Server background, getting fully into the Microsoft Azure, day in, day out, deploying enterprise scale landing zones, putting down massive WVD environments. It's been absolutely fantastic.
Just on that, so we've got a public case study that we're going to do for the University of Glasgow, where we designed and deployed from a standing start 72,000 users a WVD environment. That's going to be a public case study. The customers also agreed to do some sessions with us. So in a few months, we'll give you a real customer success story on how to do WVD at scale, how we push the platform to its limits, and the pitfalls and the learnings we got from that as well. So looking forward to sharing that with you guys if you get the opportunity. So thanks, John. Thanks for the opportunity again. And great to meet you all. Have a great event and speak to you all soon. Thanks.
Cheers.
Thanks, Des. Yeah, appreciate that. And thanks, Reese. I mean, it's great to hear that story, to be honest, Reese. And obviously on the point of our sponsors, Servant have been a huge support to this user group. You know, obviously giving the finances, helping us with ideas. It's all about that, and it's really great. We've built up some great friends, and in the process of doing that. At the same time, huge thanks to Servant. We do have another sponsor to the group, and that sponsor is Admiral. Again, between I don't think Luke is on, but Luke Twos, he supports group. He jumps on our weekly calls when he's available. Between Admiral and Servant, it's these guys, these companies that kind of keeping these kinds of user groups, supplied with prizes and all sorts of things. So, hopefully we'll be able to squeeze a few pizzas out of Des's pocket when we actually get to doing some face-to-face meetups. But sticking with Admiral for a quick second, I mentioned Luke, and funny you say that, Reese, because I think we're all in this rapid expansion at the moment. I don't think there is a company that isn't hiring at the minute in the cloud space. So on that note, Luke's asked me to put this message up. If you are in Luke's position, you're joining this for the first time, or the second time you're looking to start your career, drop Luke a line. Obviously, drop Des a line as well. I'm sure between the two sponsors, there are some opportunities. So make a note of his details there, and reach out. If it's something that you're looking to do, or you're looking to change your career, whatever it is. There's always opportunity out there, and we've got some great contacts between Luke and Des that can help you out. So thank you so much to Servant and Admiral for obviously being a huge part of this group. It really is appreciated. So with that, let's crack on with the content. So I'm going to hand you over to Anirban, who is going to talk to us all about some Kubernetes. Over to you, Anirban.
Thanks, John. Can you all hear me?
Yep, loud and clear.
Okay. So yeah, it's great to be here. Thanks for having me in the session today. So I'm going to talk very briefly on what we at Cognizant have been doing for the last 2 years by supporting an ESS platform for one of the top 2 universities in the UK. So it's mainly sort of like we have existing monolith, and besides that, we are trying to build capabilities on top of that monolith as a kind of microservices. And
sorry to chip in, Anirban. Have you got any screen to share?
Yeah. I'll just bring it in a minute.
No worries. Okay,
yeah.
No worries. Sorry.
Yeah. So I think, we have a monolith, and we have this containerized API deployed in AKS to cater the wider needs and across organizations. So I'll just bring my screen up. So let me know once you see it there. Can you all see it?
Yeah, got you.
Right, okay. So I'll start with the problem statement. So this is what we've been trying to do, and we are supporting a platform, as I've said earlier, and it's completely been blends of the existing IaaS, iPaaS, as well as PaaS workloads across Azure. And we have several capabilities in the monolith. So we have content authoring, center management, e-commerce, test taking, examiner marking, and external auto markers through the APIs as well. And we are doing the result calculation as well as giving the reports to the end user as a formal examination report. So recently there was a kind of greater focus on spreading the English on specific geographies. So it's mostly like the Latin American countries where the focus is not that great at this moment. So they wanted to just have their reach widened. And they wanted to kind of use all the reading, listening, and writing content spread across with the decisions like to leverage the existing platform that we have, and obviously knowing it's monolith and it has all the features. So we were not that confident that being an MVP will be able to meet all the targets and all. So what we decided was to kind of run the API integration workloads on AKS so that we probably be in a better positions to meet the NFRs. So we have worked very closely with Microsoft through this journey for the last 2 years, and we have evaluated various options. We have tried with ARO, but being the initial investment that it normally takes, we kind of shifted from that focus, and we tried with Service Fabric as well. But since it's completely .NET centric, we thought of like AKS would be a better choice. So right now, the position that we are in, I think we are running with 6,000 concurrent test takers at this moment without any glitches, without any single packet drops. So I think it's giving a massive performance boost to the existing monolith kind of with a zero downtime deployment as well. So, I'll just quickly take you guys through the architecture that we have done. So the integration gateway, as you can see in the top left, it's completely hosted on AWS Microsoft. It's a polyglot in terms of cloud that we see here. But once you enter that integration gateway and comes to the front door in our layer 7 proxy, so we have web policies just to take care of any external vulnerabilities like the normal XSS attacks, SQL injection attacks that's been all prevented there. And it actually enters into the Azure Kubernetes service in the actual VNet subnet. So in the subnet, we have NSGs, which is taking care of only the incoming traffic from the front door service stack. And then once it comes into the backend, we have the Nginx public IP, which is being hosted with a proper CNAME mapping to a domain name server. So that Nginx actually connects to different services in the backend as kind of like path-based routing that we normally have. And then those services are completely written on .NET 5. And we have started with .NET Core 3.1, but eventually for a big greater performance benefits that you can see in the Microsoft blogs of late, we have moved and migrated completely to .NET 5. And it was giving good performance, but there was a lot of throttling on the initial Kubernetes node pools that we had. And of course, without knowing the system much, without knowing a great deal of Kubernetes, we started with only one node pool. And I think we started with 1.14, the versions that AKS had that time. So obviously, it was not supporting multiple node pools, if I'm not wrong. So later on, they started adding up the features of multiple node pools. So we have kind of segregated the resource-hungry APIs to different node pools, and obviously it showed up in the benefits. I mean, the queue length initially it was 64 because of the throttling. Now it has come down to almost 0 and sometimes become 1 or 5, but it's eventually giving a great performance. And of course, with .NET 5, it comes with gRPC advanced changes, and we have taken gRPC as well. And it's giving a greater benefits in terms of like higher throughput and almost nil latencies in terms of the requests that you can see in the queue. So as you can see in the top, in the right in the screen, I think it's connecting with all monolith that we already have. So SQL Azure and Redis and storage and service bus as a message broker is all tied to the existing monolith. So we are, as a service stack in this complete architecture, we are trying to just share the backend, but not from the container APIs perspective, but still we are trying to, I mean, it's kind of a strangler pattern you can see. I mean, we are trying to just develop the capabilities, and once we establish the full end-to-end circle, we're just trying to replace that existing monolith capabilities with these services. So that's how we are kind of going by this. Of late, we have introduced Dapper as well as a PubSub component to this Azure Service Bus topic, and we can see great at least 50 milliseconds improvement in terms of timing, and it's actually improved the pod startup times as well. So the connected endpoints from the consumer perspective is still running on REST. So we are actually running a kind of transcoding of the HTTP 1.1 to HTTP 2.0 in the gRPC. So pod-to-pod communication is running on the gRPC, but the Nginx to the actual endpoint, it's running on HTTP 1.1. So that's gRPC HTTP API. That's one of the kind of sample project that we have used, and I think it's giving a good value in the production workload so far that we have seen. And we are running with RBAC in the Active Directory as well. So obviously we are running on the group that we decide in the AD, and of course it's actually tied up with the service principal as well, just to make sure that it's maintaining the proper RBAC throughout the kind of ACR and other pipelines and all the things that we've used. So from the source controlling perspective, we have Bitbucket, which is you can see in the left, and we are doing the YAML build, Docker build pipelines in the actual Docker build, and it takes care about all your code qualities, all security vulnerability scans, and it actually makes sure that you are running the unit test cases through. So everything else, I mean, when everything else is ticked off, it actually pushes the image to the ACR, and ACR is kind of being the backend repository of containers. I think it actually stores the Helm charts as a packages, and then later on when we are trying to deploy those multi-stages pipeline into actual Azure DevOps, it actually pulls up that charts and then deploy into the actual Kubernetes cluster. So that's how the kind of architecture has been built off. So right now we have started with 5 APIs initially, and right now we are having almost 12. Rather, it's soon be becoming 15. So I think we are seeing good benefits over there, and of course there are a few developments which is in the pipeline, which I'll just talk next. And I think from the performance perspective, initially when we started this journey, I think we are not confident that we'll be able to meet even the NFR of 5,000 users. But I think with the latest changes that we have brought in, we have confidently met about, or rather exceeded that expectations from the client. So I think we are running very good expectations from that perspective. I think we have already explained the architecture that we have just shown there in the earlier slide. I think one of the addition is we are running on HPA, which is horizontal pod auto scaling, from kind of maintaining few of the monitoring like the CPU and other monitors that we have. And of course, based on that, we are actually scaling out the pods and eventually scaling out the nodes as well through the cluster autoscaler in the actual VM scale set that we have. So I think it's pretty much everything. And of course, from the KV perspective, I mean, since it's kind of a DevSecOps perspective of that DevOps pipeline that we want to bring in. So we are using variable groups, and that actually makes sure that whatever you are using in the Azure DevOps pipeline, I mean, nothing is being exposed externally, so that you are only able to see that once you're kind of an admin of a project. So that gives us enough flexibility to put secrets in the KV and then use it across the pipeline and the stages throughout. So coming to the milestones that we have achieved in this AKS journey, I think we have started with 114 that I've just mentioned, and eventually right now the production workloads is running on 119.7, which is the latest version just before the 120 preview that we have. And of course, we have started with the configuration provider in the key vault, but then we have seen a little bit of glitches in the performance benchmarking, to be honest, and that's something I'm just running show on the ground. So that's from that experience I'm saying, like, we have tried several options. We have tried the CSI storage, we have tried with keep par file, and of course the default app configuration provider that we have for getting the KV into the .NET Core services. But I think pod startup time was almost taking around 50 seconds, and that is too much from what our client demands. So initially we started with this, but eventually actually got shifted away from this one, and then decided like we should be hosted with the environment variables, and that environment variables will be getting stored in the Kubernetes secret. So when we actually deploy those APIs, we are just making the secrets in the runtime and then deploying that, so that all the environment variables are actually being part of the Helm charts, and those variable values, secret values, being stored in the actual Kubernetes secrets. And as the best practice suggests, like once you actually going with a container, you should be making sure like it's almost security hardened and there is no glitches on the the image that you're using. So of course we make try vscan while we are building the image, and we make sure there is no vulnerabilities involved. And of course, if it does, then we stop the build there and we kind of throw a message back to the user, like the check-in that you have made actually is kind of a faulty one. You have to go and check your app upgrade in the Alpine images that you are making. And initially we started with Debian, but then it was far too much in the size. So we actually cut down to the Alpine, and we are making sure that it's running with the read-only file system. So even if somebody is getting hold of the actual container in the pod, he'll just be able to do nothing else, just to see it, but not probably do any of the changes or kind of inject any of the mounts in anywhere. So it's almost everything is sealed. And if you can see, we have introduced the pod security policies in terms of Azure policies, and we have done the bit of like using this allow privilege escalations and all the Linux capabilities that we normally offer in the security standards. So we are doing all that, and just to add up to the performance, we are introducing Gen2 VM. It will be done very shortly. And we have done this Containerd as a CRI improvements as well. And I think once you're running starting 1.18, it actually gives you the value in default. So that's what we are doing. And of course, we are running with availability zone in the Kubernetes cluster node pools to get 4 nines availability factors as well. So I think that's pretty much that I need to talk about. So just a little bit of points before I just finish off. So of course, it's been a great experience. And knowing where I was 2 years back, I didn't know anything about Kubernetes, didn't know anything about Linux, to be honest. I just wanted to explore in this way and just knew a few of the Linux command. But I think what we have seen so far with the experience that I have and the state I'm in, I think it's just a myth that Kubernetes is too hard. So definitely I would say, just sticking to the tagline, it's not that hard until you try. So I think I will request everyone to have a go at this, and then try to get a secure and scalable and kind of a resilient service that Azure offers by default. And I think it's been great experience throughout. And probably whatever plan we have in expanding this one will go fine in the line. And with that note, I think I'll like to conclude this one. So probably it's not enough to talk about all this in 15 minutes. So I tried just touching upon the points. So if you have any questions, you can just paste it in the chat. I'll try to answer to my best of ability. Thanks, John. Thanks everyone in the session.
Thank you, Anirban. That was brilliant. Great to see. And I'm not going to profess to try and ask you any questions on Kubernetes because I won't want to embarrass myself. You do have one question, though, in the chat. I don't know if you want to just expand on it. So, Hugh, I don't know if you want to come off mute and just ask your question, Hugh.
Yeah, hi. Can you hear me okay?
Yeah, I can hear you. Yep.
Yeah, so what I wanted to ask was, Dapper's fairly new, so you must have started using it really before it was that mature, or certainly before it hit GA, or it.
Yeah, so we started using. Yeah, so I got your question. I think I've seen in the chat. So I think we have started using from 1.0 when it actually came to GA. Before we had a few tries, a few of the earlier versions in the preview, but I think it was not a very nice experience. So right now with 1.0, and of course it has actually come up with a 1.1.1 upgrade in the last 3 days. So we are using that, but only the PubSub component of it. So not everything like the state or the monitoring or the other components that Dapper offers like MTLS and all. So we're not using that, just the PubSub component, but knowing and seeing the behaviors, I think, except one glitch that right now it has, it's like if the cluster restarts itself, because of the cost saving measure, if you just are trying to start and stop the cluster for the non-production workloads, when the cluster restarts, I think Dapper works this namespace, right? It stops working. So the sidecar actually that kind of if you're running threes sidecar in at the minute, so it'll say 3 by 3, but that actually becomes 2 by 2. So Dapper actually stops working. So that's something we are trying to figure out like how to improve that one. But apart from that, I think it's a pretty nice and stable experience that we have got so far.
So you would use it again in your next project?
I think so. I think so, because obviously the benefits it does and gives you in terms of tagging with the other backend services in terms of like message broker or maybe the Redis state or maybe Azure App Insights or any other components, right? I mean, it's good. It's good.
Cool.
Actually, it takes away all your effort to make the clumsy code in terms of like if you want to let's say integrate with Azure Service Bus. So you have to use the SDK, you have to maintain that SDK, you have to just make sure that you are creating the clients, creating the instances, and then just doing all sort of garbage collections and everything pretty okay, because Azure Service Bus is not that user friendly in terms of .NET Core SDK. So I mean, I think with Dapper, it's just about 2 annotations in the actual Helm spec that takes it. That's about it. If everything is being taken care of internally.
Cool. Thank you very much.
No, cheers, Hugh. Thanks for the question, matey. I don't know if Toby if you spotted that one there from Toby and Anirban. We've got a minute or so.
I think you might have answered it already. So I was particularly interested in the use of gRPC and what problems that solved for you. And obviously, gRPC is sort of fundamental to the inner sort of workings of Dapper. And I was interested in, and I think you've said actually you used the PubSub aspect of Dapper, really not really anything else. So it sounds like you were using gRPC for other kinds of interop, and I was wondering what prompted that.
Right.
I think I saw something on a slide about disk IOPS or something. So I was just kind of interested in that.
Yeah, exactly. You have actually picked up the right thing. So initially, when we deployed all the APIs with .NET Core 5 or 3.1, we have seen there was a disk IO throttling. It was actually kind of exceeding the queue length that normally Microsoft suggests as a best practice of 8. And our API were giving around 54 that time. So we have started with a lot of research because since it's Linux system, everything you access in the actual OS, it's completely in the file. So we started with minimizing the effort and the secrets. We taken away the KV and we started with different introducing async await more to our .NET Core and all. But eventually what we have seen, like the queue length was not actually coming down over 40. So then we started reading out the gRPC notes that came up in the .NET 5 release with James Newton. So just wanted to have a try with it, and eventually it turned out like with gRPC and .NET 5 as a combination, so I think it bring down our entire queue length of throttling from 54 to absolute 0, and that too in the performance environment when we are running the JMeter script of 6,000 concurrent users. So that actually did a massive boost. But then there was one of the flaw that we have noticed. I mean, we know that it's JSON is 1/4 of size of, sorry, the proto is 1/4 of size of JSON. So obviously it actually takes a lot of effort away from the networking perspective. But the thing is, the client side, the consumer side of gRPC services, which is actually consuming your service, has to have the gRPC client also inbuilt. So that's one of the bottleneck that we had. And that's why we had to introduce the gRPC HTTP API as a transcoding layer, so that you are having this HTTP 1.1 request coming in, but then you have the transcoding layer inbuilt, which is actually transforming that into 2.0 and then sending it to our pod. I mean, that's the aspect that we're using now. So I mean, the ideal practice is to use the envoy proxy, but we are not using that since it's a .NET Core environment completely. We are using the ASP Labs HTTP API for this moment.
Thanks.
Thanks, Toby. No, brilliant. Thank you so much, Anirban. That was fantastic. And obviously, feel free to ask any more questions from the audience there, and I'm sure Anirban will pick those up. But if everyone wants to come off mute and thank Anirban for his fantastic talk.
Thank you.
Take care. Thanks, Anirban. Right, we shall move swiftly on. Vukašin should be in the room there. I did spot you earlier. Are you there, sir? There he is.
Yes, I am. I hope you can hear me.
Yeah, loud and clear. Over to you. Thanks.
Thanks. Perfect. So that was a great session, and he actually showed a lot of Azure diagrams, which is which is great. That is what we will be talking about today. So I only have one slide, and then we will jump to demo. So my name is Vukašin Terzić, and I work as a cloud solution architect. And as the name of the role might suggest, I have to create cloud solutions architectures. And that requires a lot of writing, unfortunately, and drawing different diagrams. And I personally prefer seeing the good graphical representation of the solution rather than reading everything in many, many pages in the document. And I found out that to be a case with my customers as well. And a good and updated architecture diagram also plays very big role in day-to-day operations when like you're sorting out some critical case at 2 a.m. in the night. You don't want to read anything, you just want to look at the document. And also I find out it helps very much with Azure governance. That's maybe a hidden aspect of it, but having everything represented in a graphical way, what goes in which subscription, where are they located, how networks are connected. It saves a lot of time with the governance as well. And so I create those diagrams almost every day. And now, unfortunately, in this session, I'm not going to show you how to create Azure diagrams. That's not different from drawing on-premises infrastructures. That's the same. But what we are going to focus on today is how or where to find the icons and reference architectures to help you start creating Azure diagrams and properly representing all those different Azure services in Azure or in your Visio diagram. Now, that we have the expectations set properly, that I'm not teaching you how to create diagrams, just showing where to find the tools you need. As I said, I work with those diagrams every day, and I'm happy to like help you review whatever. If you need any help with Visio, feel free to reach out outside of this session. I'm happy to help because that's something I do daily. Right. So we have a Visio. And in this here, I have my company Visio Professional. There are different versions. Some of them might not have what am I going to show you, but that's not a problem. We will show that in a different way later. So when you run typically and you try to draw something in Visio, then you want to draw something and then you find out that you might not have the proper shapes, right? You want to show Azure subscriptions or something, and that was missing because you never downloaded it or imported it or anything. Good news is that Microsoft is of course aware of this, and so by default now we do have some representation of cloud services, and not just from Azure, but also from different cloud providers. And this comes, as far as I know, and I tried to install Visio on a new computer, so it's just, this is not something that is left over from some things that I imported. So I found this to be the case on a brand new computer, brand new installation of Visio. You already have some tools here to represent, but this is not everything. So you will definitely miss some icons here, but this is a great start. So if you want to draw something, you will just go to network, find, and you see that this is very limited, but you get those icons so you can draw your virtual machine. So that's the first step, right? And then you will continue with connecting them and representing them in the rest of your Visio design. So first thing to remember, under network, we do already have some shapes. They come with your Visio installation. Another great thing to know is that when you try to create a new drawing, no, no, you go new, you can select the template. That's what I wanted to show. So now you go to templates, and again, in the enterprise version of Visio, this will be called different. I think it's called cloud and network or something like that. I do have that version on the other computer, but the result is similar. Here we go under the network, and here you already have some Azure diagrams like templates existing for you that you can use. And so you can see here that you can select one of the templates. So something, all right, let's use Jenkins server, create. And now, great thing about it is first, of course, you get a template that you can use, move things around, add some new icons. Of course, this is not going to fit your solution, but you already have the entire environment here prepared. So that's another trick that I didn't know in the beginning. Now I know, now I use it all the time. Oops. And the other thing that comes with it is that you see those, you already have those opened here, but those shapes that we see here, those are the same that you can select from here. You see they are checked because they are used in this template. Right. So this is how far, this is as far as the Visio itself will go. And you can see that you can do basic things. So if you are doing a simple diagram representation of the, I don't know, your subscriptions and your services in those subscriptions or virtual networks or something like that, this should be enough. But of course, this is not updated all the time. And as you can see that this is definitely not, for example, those are not all the icons related to the databases in Azure. But the basic is there. Right. So what if we need more icons? Well, we have to download them. Right. So that's the first thing that we can go. And Microsoft before, and this changed over time. I had to update to find all the new links and all the new names actually for this demo, so I can show you because I already have like some older versions of everything. But now if you go to this website, I can share those links later. And here is the up-to-date, and it's 1 year old, but those are the up-to-date icons. Or actually, no, there is January 2021 update. So the newest icons directly from Microsoft, representing most of the Azure services, are available for download. And this is great because when you create a diagram, you will find out that Azure itself, of course, is not enough. You combine a lot of things. You combine on-premises, you combine Office 365, maybe AWS, some other services. So, of course, this is not all the icons you need for your diagram. You will also have to download, for example, Office 365 licenses. But there is no like publicly available link like this provided by Microsoft that you can use to download Office 365 or M365 icons. Yes, there is, but not publicly like this. You have to go to Fast Track and download it from there. And this is great that actually Microsoft realized that for Azure, we have a lot of icons, a lot of services. And before in the local diagrams, we were just using the server icon, and that server was representing everything from Active Directory to whatever else. Now, we have to be more specific. So we have icons. Great, yay. So now we download the icons. Here's the file. And when you download the icons and you unzip them, of course, you get all the icons, and you get some terms of use, which are actually written also here, what to do, what not to do with the icons, of course, and then you get a FAQ. When we open that, oh, that's too small, let's make it bigger. Are these icons available in Visio? Not yet. So that's the first thing to realize. We don't have a VSS file that we can upload or import to Visio to get all of those icons. That file did exist before, and I can show you that here, that I do have some of those icons. That I do have some of those icons here already imported, but this is the old stuff. This is not being updated anymore, and it's not available for download anymore. Okay, so that's what we read. So what we get instead, we get the SVG icons. And that's actually great because not only you can use them in Visio, but you can use SVG basically anywhere, right? You can use it in your designs, in your Word document, and it doesn't lose the quality when you put it up or when you scale it up or down, right? And so those are the SVG icons represented in groups, which is great. And yeah, you download the icons, you can see the icon. Okay, this is small, and you can use it. All right. So what else we can do? Well, and now of course you can import this icon into your Visio. Because we are running out of time, I'm just going to jump on another thing. On this same page, you have a link here to go to browse Azure architectures. And this is also great. Here are some representations of Azure architectures that you can use to also as the templates in Visio, you can use them here. But if you search here for Visio, cool trick, you can open any of those templates and you will see that it contains a Visio file download link. Great, so you can download this entire file, import it, work around, change it, make sure you are able to use it. Before officially existed something different, blueprints, but you see this is very old article and it's not being updated anymore, and those links for downloads don't work anymore. But this is really cool, where Microsoft was showing us how to make a 3D representations in Visio. But let me tell you something, this takes a lot of time. Okay, and then the last thing that I wanted to show you is that you can use also something called Icon Downloader, which is a Chrome extension. This was before called Azure Icon Downloader. Now it's called Amazing Icon Downloader. And what happens is that when you install this in Chrome, you get this icon here. And now when you are on Azure portal, you can just click here and it will show you all the icons you have here on the page that is opened. And you can download them individually as SVG files. So if you are searching for something that you cannot find, but you are able to find it in an Azure portal, then you can use that and download your icon and use it immediately. So if you don't want to download the entire Word, you can just use this. Okay, and then the completely last thing that I want to show you is that now we have more and more tools. Doesn't want to switch. That help us represent graphically our environments in Azure. And one of them is ARM Template Viewer, which basically it's the extension for Visual Studio Code that reads your ARM template and create a graphical visualization from it. And that's also great because you can use those in your diagrams, or it can help you create a diagram as you want. We also have a PowerShell modules that can do this now, and we also have different templates from different users, not templates, sorry, extensions that do the similar thing. Okay, a little bit over time, but I did it. That's all for my session today. Let's just check if you have any questions.
Thanks a lot, Vukašin. Yeah, I think there's a couple. I think in summary, I think a few people have asked, obviously Visio is a paid for service, yeah, from Microsoft. I'm not aware that they do a free version other than a viewer.
No.
I suppose the questions generally are you aware of any kind of open source free versions of kind of Visio style? I think we had one mentioned in the chat there. Is it draw.io, something like that? Resharp, was it?
Yeah, that one. Well, I was going to say that one. Right. So let me see if I can open it. My Teams disappeared somewhere. Yeah. So the Visio is, of course, paid version from Microsoft. It's not included in the Office 365. So it has to be charged extra, and maybe your company is not going to provide it for you, or you're working on your own. So they definitely are. I don't want to waste too much time. I'm going to type those links, what I am aware of. I'm going to type those links in the chat.
I think Resharp was just asking if you knew of any kind of key differences why you might want to pay for Visio over some of the free versions. Are there any obvious things that you've come across? I think was the theme of the questions, but
it's hard for me to compare that because I'm using Visio for like many years now, and I always had it. So I never worked like full time in different free version of the software. So it's very hard for me to compare, and because I was lucky enough to always have a Visio provided by my employee.
Brilliant. Thank you so much for doing that session. I think our next speaker, our own Matt Fortunka, was trying to steal your thunder there halfway through the chat. So I think he just wanted to start his chat early. But no, if everyone wants to come off, thanks, Vukašin. But no, thanks, Vukašin. Thanks so much.
You're welcome.
And on that note, over to Mr. Fortunka.
Yeah, thanks for that, John. That's much appreciated.
I just thought you wanted to start your talk early, by the looks of it.
No, I have to apologise because I preempted part of your talk. That amazing icon downloader is really handy.
Thank you. It was a different extension before, but now it's called differently, and it works for many different websites. I didn't mention that, but it also works for different websites that are also supported. If you just browse the website and click on the icon extension, you will see if any icons are available.
It's one of those hidden secrets. It's great. So, hello everyone. For those that don't know me, I'm Matt Fortunka. I'm a cloud solution architect for Microsoft. I tend to specialize in the application development, application innovation space. And I spend a lot of my day building APIs using various Azure services, building and consuming, should I say. And for years, I think my go-to tool was something like Postman, or if I was feeling particularly sadistic, Soap UI. Now, these are great tools and they do the job, but there's a couple of drawbacks to them. Firstly, it's a separate app. I don't want to have to open a separate app. Everything I do and everything I do on a day-to-day basis is in VSCode in one form or another now. You know, my C# lives there, my infrastructure code lives there, my unit tests live there. You get the idea. And then all of that code lives in a repo somewhere, and actually integrating something like Postman or Soap UI with a Git repo can be quite challenging. I just want something that lives alongside my project. It'll come as no surprise given the slide that's up there, and this is the closest I get to a slide. This is a markdown file with running in preview in VS Code. REST client is the kind of solution to that. Now, you may have already had REST client installed in VS Code, particularly if you've done anything with API management. If you install the API management extension for VS Code, and there's the page for it, and click on the dependency page, there it is. It's loaded in as a dependency for that that extension. And the way that it gets used in the API management extension is if you go and browse to an API management instance and go and find a particular API you want to call, and then right click on something and go test operation, it'll generate you a file that you can call from within VSCode. And that's great, but it's a great resource on its own. And there's a whole set of features that I just wanted to go through very, very quickly to show off. So I've got, as you've seen, I've got some API management instances running there, and I've got a whole set of APIs on there, and we're going to go through and call those. There's the extension if you want to see that in full, and all the documentation is on there as well. So I've got an operation there, and I'm just going to create a sample request. So I'm just going to create a post request, and it's not going to do anything particularly clever. It's going to call API management. It's going to specify it's a post request. It's going off to this URL. I'm passing in this subscription key and some trace information and a body, and I'm just passing in a JSON payload. Now from that point, I can now just hit within my VSCode instance, send request, and I get my response back. Really handy. I can then save that response body out, so I can copy that to a clipboard, so I can then go and paste that into a JSON file and do some analysis on that if I really wanted to. But you know, this format may not be the right thing for you. So if I hit F1, I might want to generate that as a curl request. And I'll drop that into another file, wrap that around, and now I've got a curl request, and I can do exactly the same thing from there. I can hit request, and it does exactly the same request, format it slightly differently because it's got it's removed all the white space carriage returns in there, but it's done the job. Now, again, that's great. What if I want to take that example and then apply that to some code? So I can now go and highlight that, generate code snippet. If I want to have a look at C#, it'll give me the option to do either the REST Sharp library or the HTTP client library, and will generate me a code snippet that I can use straight away in my projects. Same with JavaScript. And then I get the option, do I want to do a fetch? Do I want to use Axios? Do I want to use a straight XML HTTP request? Let's do a fetch one. There we go. And it's generated me the right request that I need to paste into my code. Really handy. Now, there's a bit of a problem with this, is that I don't want to have to check this file in because it's got this wonderful hyper secret subscription keys floating around in there. And what I want to be able to do is to move that out into effectively my user settings so that they don't get committed, but every time I run this, it's going to pull those values in. And if we go into my settings file, I can go into my settings.json, and these settings can exist either at a user level, which means they're in my Matt Fortunka user profile folder, or they can exist as a settings.json file within this workspace as well. So if you've got super secret stuff, put it in the user file. If you've got stuff that is just configuration values, stick it in the workspace, and those settings get blended together. So I'm going to go and edit my settings. And you can see I've actually already put in my subscription key in there as a setting. We're going to go back to here. I'm going to replace it using that syntax. Now at that point, that's still working. So I can commit that file in. And actually, if you have a look at the API management, when the request gets generated by that, that does exactly the same thing. And it even gives you some instructions as to what you need to do. But that's not all. I maybe want to change that host name as well. So I want to pass that host name in as a parameter. So I'm going to grab that chunk there, replace it with that into my settings file. We're going to add a new key in there with that value. Then I'm going to copy my value in again. Save that little lot up. Run again. Great. So we're now using variables within our REST client. Now, let's go to a scenario where I've actually got that API now deployed to 3 separate environments. So say I've got it deployed, I want to run it locally. So I'm using the like a functions emulator or something like that. I want to deploy it to my dev environment, and then I want to be able to call my QA environment as well. So I can make use of a feature called environments. So I can define an environment called local. I can move those settings out from there into there. And do the same with dev. Copy them. I haven't actually got another API management instance, but I'll just copy those values in as well. And then likewise for, what should we do? QA like that. Okay, so I've now got 3 environments set up plus some shared settings. If I go back to my call now, I now need to select which environment I'm going to use. So you might be able to see right down at the bottom there, I've got this little thing that says no environment. If I select that, it's now going to prompt me which of those 3 things I've just created I want to use. So I'm going to set dev, and now that call works. If I wanted to test my QA settings, I'd select my environment, rerun, that would be running against QA. Really handy if you've got the same API deployed to multiple environments. And there's a whole load of other stuff you can do with those settings. You can generate GUID, you can generate date times, you can pass in random values. There's a whole set of almost like micro language on defining those variables. So for the last bit, I've got another API. And I've got another API that needs to sign in against my Azure AD. I've got an Azure AD service principal that's set up with a client secret, client ID, client secret, and I'm going to call my API. And my API expects me to. There's my API. It should just work like that. If I then call that, I should get an unauthorized response because I'm not passing in an access token, right? So if you've ever done any kind of OAuth style APIs, you've got to go off, call an endpoint, grab the bearer token out of that, then stick that in your authorization header for your API in some way like this. So I've got this is my request out to my logon. And I can have multiple requests in a single file by separating them like that. So I'm now going to go, I'm going to make that request. There's my access token that's come back. I'm going to grab that access token. I'm going to go into here and I'm going to go authorization, bearer, paste all that in, wrap that so you can see it, send that request. Hurrah, works. I've made a successful call. That's a bit of a pain though, to have to do all those steps every time I want to call something. So we can make use of named requests. So I can say in here that this request up here is going to be hash at name is auth, I think, that. And then in here, I can say, I'm going to paste it in so I don't make a mistake. We're going to use this. So I'm going to say, go find the request auth, get the response body from it, and then extract the access token from it. Right? It's blue at the moment because it says that I haven't actually sent that request yet. So once I've sent that request, I can close that one down, and now I can call this multiple times as long as that access token is valid. So it'll just use a cached version of that access token. But that's a bit of a faff still as well. So let's get rid of all that. And let's just replace it with this line here. This is one of these magic tokens that they've got in this meta language. And it basically says, using the settings you have in your JSON, which is these settings here, go off and get a new token for this request whenever I need to make it. And it effectively wraps that whole login.microsoft.com address to allow me to make that call. So I think that's me just about on time. I would heartily recommend, if you haven't, then go and investigate the client itself, the extension itself. You can find it in the extension store. But like I say, there are all things to do with, if I want to generate GUIDs or random ints or timestamps or whatever else you want. So yeah, I would heartily recommend everyone tries and then let me know how you get on.
Awesome. Thank you, Matt. That was great. You know what I'm going to be playing with for the next couple of weeks now, don't you? Wait for Twitter to explode with my random pictures. Brilliant. Have we got any questions in the chat? I've been trying to keep up, but I'm also downloading the SVG icon installer as well. So, did we have any questions? Does anybody want to?
Haven't seen any.
Brilliant. Well, if there's any, obviously stick it in the chat, and I'm sure Matt, you can jump on it.
You know where to find me.
Absolutely.
That's where you find me. Just there. There we go.
Thank you, Matt. That was brilliant.
No worries. Thanks all.
Okie dokie. Let's give him a round of applause. I'm seeing all these random virtual clap signs turn up on the screen, and it's obviously affecting my ears. Cheers, Matt. Okie dokie. Right. So hopefully you've enjoyed the format so far. Like I said at the beginning of the session, we're going to try and keep some of these lightning talk sessions up front and kind of switch then to more of a traditional length talk. So without further ado, our guests for this evening are Mr. Pete Gallagher and Mr. Liam Gulliver, who are with us on screen. And I'm going to hand it over to you guys. Thanks for joining us.
Thanks very much for having us, John. So let me just make sure I can share our screen.
Liam and I gave this talk once before, and we haven't practiced it since. So I can't remember what we did.
What could possibly go wrong?
A voyage of discovery for everybody, in fact.
So yeah, once again, thank you, John, for having Pete and I.
Thanks, Ryan. Yes, yeah, like a horrible disease. I go everything.
So tonight we're going to talk to you about controlling robots remotely with Azure. We're also going to touch a little bit. I think Pete would touch on a lot of IoT. We touch on VR. We touch on Azure. We touch on UCAVs, UAVs, kind of pretty much everything. And then you'll also get to control the robot arm from your very own homes as well as we go along. So first and foremost, I mean, John knows Pete and I anyway because he does a lot of stuff with us already. But you probably want to know why Pete and I are probably qualified to talk about this. And in our humble opinion, we never are. Yep. But I am Liam Gulliver, and by trade, I'm a DevOps consultant and cloud solutions architect for MMT Digital. And I've spent the last 16 or so years in software engineering organizations and DevOps, and was a software dev, and it's around sort of classic ASP, moving into .NET, and then made the jump to DevOps, and now spend a lot of my time in the dark side of management. I also managed to organise another meetup in my spare time, which is DevOps Nuts. I'm also one of the hosts of the Agile Engineering podcasts, Azure-ish Live and Azure-ish After Dark, as well as one of the creators of the channel that John's quite heavily involved in as well, which is the Azure-ish Live Twitch channel, with lots and lots of stuff that comes up from there. Pete?
I do everything. There's just lots of words on there. I'm an IoT consultant, so I've been doing that for myself for over a decade, but professionally for over 2 decades, since before there was since before there was an IoT even. I'm a Azure MVP and a Pro Site author, and I run Knots IoT and co-organise .NET Knots, and like Liam, part of the Azure-ish Live channel and the Agile Engineering podcast and STEM ambassador, and I like to have lots of fun with IoT, so that's generally where you'll find me dabbling around.
So quick overview of what we're going to be going through this evening. So we're going to give you an overview of this project that Pete actually did a fair amount of the work on, I'm not going to lie. And the architecture, we're going to talk to you about .NET 5 and GPIO on the Raspberry Pi. We're going to talk through how the robot's been built. We're going to then touch on our interface side of things, which is all through Blazor and SignalR. We're then going to also deploy an update to the application through our CI/CD pipeline in GitHub with GitHub Actions. And then we're going to get to let you guys loose with it and play with it all at the same time in kind of that Twitch does Pokemon fashion. So right now, what we've actually got is the robot arm is sitting in Pete's house. I'll be able to control it from here, and we're going to do it through Azure, and you'll have a web interface where you can do it, and you'll be able to see it all live. And then we'll round off at the end with sort of expanding that further with also controlling it from an Oculus Quest as well. So now, what we're going to be doing, or what we've done here, is a fairly rudimentary example of some really advanced tech that you can also see today in all sorts of applications, from unmanned aerial vehicles through to Mars rovers, through to remote control surgery robots. What we've done here is a real, I wouldn't let somebody using this robot arm do surgery on me, but the concept is still the same. It's very much a hello world of that way of working. And as we get into now more than ever with COVID and everything else, and needing to be able to do things more socially distantly and also on distant planets, this is the kind of thing we can expect to see. So, Pete, I believe this is your bag.
No, I can't be bothered. Have you got slides in the deck here? Am I doing I'm doing the next slide, please. Which
yes, please.
I suppose I could request control, couldn't I? And then I can do it myself. So if I just click that button, you can click that allow, and then I can.
What if I said no?
Well, you just have to do the next slide, please, and we both look stupid. So yeah, normally it's really hard to do .NET on a Pi. Well, not really hard, but there's quite a lot of install stuff you've got to do. There's no apt-get install for Raspbian, sadly. So there's a bunch of tutorials out there, but there's a whole heap of steps. And if you're sort of relatively new to Linux, it's relatively difficult. But I've made a single line install script that you can see here on the screen, and that just installs everything you need on the Pi. You just do a reboot at the end, and you're off and running with .NET 5 in this particular case on the Pi. I will do a .NET 6 version of this script at some point when I get some actual time, which I don't appear to have any of at the moment, and I know Liam falls into that same category. So yeah, that just makes life so much easier. You can see all the steps there that you would have had to go through manually before, so that sort of shortcuts all of that. So that's nice. One of the things that you rely heavily on when you're doing any form of IoT with C# is this system.device.gpio NuGet package. And that gives you access to not only the breakout pin basic I/O for turning LEDs on and reading buttons, but it also gives you things like PWM pulse width modulation, which we'll talk about in a minute, and serial interfaces like plain UARTs, and I2C and SPI and stuff like that. If you do have other boards do exist, then this will support them too. And it also supports the unsupported Windows 10 IoT. I don't think there's been an update of that since like October 2019 or something. So there's no real need for Windows 10 IoT anymore, I don't think. Not with things like this and things like the Uno platform that give you the facility to make UIs. So yeah, just go ahead and use full fat Raspbian. You can obviously install that NuGet package however you like. I will be doing it through the CLI if I show that bit. If I don't, then believe that's what I did. GPIO, worth talking a little bit about that. So if you don't know, that's general purpose input output. And this is how the Pi is going to interface to the real world and control things like LEDs and read things like buttons and more advanced things like servos and things like that. There are two numbering schemes which you'll see when we show the code. There is the board numbering scheme, which I far prefer because I can count. And pin 1 is that square pin that's slightly chopped off top left-hand corner. And then opposite that is 2, and down is 3 and 4. There is this BCM numbering scheme, which is referencing the BCM chip, the GPIO driving chip on the board. Don't use that, because now you've got to convert between that number and the pin number. So just use the board numbering scheme and be done with it. It just makes life so much easier. All of those pins have got, everything you'd want to control the real world. You don't need to go any further than that, but should you need to, then there are hats you can get, hardware attached on top you can plug on, and you can have all sorts of nice interfaces, like a Sense hat, for instance, that is attached to a couple of Raspberry Pis on the space station. When Tim Peake went up there, he took them with him. The control for our robot that I've got sitting on my desk here, I chose to use this Servo 6 board. There are a million different ways to do it. And I could have used like an SPI or an I2C PWM driver board if I wanted to, PWM pulse width modulation. Again, I'll talk about that in a minute. But I wanted to use the system.device.gpio as a learning tool. So I wanted to drive the PWM directly. So one of the things you can't do is plug these servos, these mini little motors, directly into your Pi, because it can take about 300 milliamps, and each one of those GPIO pins is only really rated at about 30 milliamps. So it might seem like it's all right for a bit, and then it'll stop working forever. So this board splits out the power from the control. So I've got a little battery pack that I'm hoping doesn't run out during the talk, and that just sends the necessary power to the servos, and all of the rest of the wires are just for the control. So that's sort of how that works. So building the robot. So that's the overall circuit you can see there with the battery pack. Down there, we've also got a little LED and a resistor there on the left, and a button, which is the standard Hello World project that you'll do with any IoT project. Let's flash an LED and let's read a button in. But it really is the best way to start.
Pointing out, Pete, that we need a battery pack, because the power draw from the Servo 6 board, well, the servos as well, I think, isn't it? It's just a lot more than we can put through the Pi itself.
Yeah, that's right. Yeah, it's 300 milliamps normally for a startup current draw from a servo. So, yeah, don't connect that direct to your Pi. That would be bad. I 3D printed this robot. There's a GitHub link for all of the code that you're going to see, and actually, there's some 3D printer files in there for a robot that Cliff Aegis and his son have designed, which is far simpler. It took me about, I don't know, an hour and a half to assemble this robot. It was fairly complicated. But Cliff Aegis is you get the 3 servos and you just screw them together, and that makes your robot with the parts. So the 3D printing files are in there for that. Here's the connections from the Pi to the Servo 6 board. So you still need ground. And in fact, if I was to speak to the person that made the Servo 6 board, I'd say that's quite complicated, the way that you've labeled those pins up there, because I connected pin 1 to pin 1, but it's not that ground to the right-hand side is actually ground. So that's just something worth bearing in mind. This board's about, I don't know, about 10 quid or something. And again, there's cheaper ways of doing this. You can get PWM driver boards for a couple of quid, but this serves the purpose. And then on pin 35, pin 12, and pin 13 are the control wires to each of the 3 servos.
Is there just quickly, because I know we've done this talk a couple of times now, and I always have probably the same questions because it never sinks in. Well, is there a particular reason for using those exact pins?
Yeah, they are the PWM pins. Well, 2 of them are. That pin 35 and pin 12, they're the 2 hardware PWM ports. It's sort of spoilers, this is. Pin 13, that's just a regular GPIO pin, but we'll come back to some of this when we see the code. Just as a bit of a reference, and I think this GIF's stopping and starting, but PWM basically works where you're looking at the width of pulses. So you can see here, those long pulses will move the servo to the right, short pulses will move the servos to the left, and regular size pulses will move it to the middle. And that's kind of basically how it works. And it's floating in that particular position, and you just move it by changing the width of that pulse. It is slightly more complicated than that, but that is the basics of how that's working. I know that John's quite right. He's bought some bigger and better servos. We're using what's called, I think, 10G servos or something they're called, and they're like I don't know, £2 for about 650,000 of them. They're dead cheap. But you can get slightly more powerful servos that will just have more torque, more lifting power. But these ones work just fine. And again, all of these details are in the GitHub link that either will be on a slide or I'll just pop a link in the chat in a bit.
So, do you want me to do this bit?
Yes, let's swap over.
Cool. So let's get on to the actual interface. Now, we have got, I mean, ultimately, there's lots of ways you control these arms. I'm sure you'll have seen a few times where, folks have put levers in to do these kind of things. But what we wanted to do was something more crowd-friendly, I guess, is the way to look at it. And also we want to play with Blazor, WebAssembly, and SignalR. And if you've seen any of our shows, you're doing a lot of work with that at the moment as well. And it's a really strong tool set for us to be able to use, especially with .NET 5. So why do we choose Blazor? I mean, one of the things is it started out as a little pet project at Microsoft. Another thing is, frankly, I don't think Pete or I could really be bothered to go and learn React or any of those JavaScript frameworks either. But what we do know is .NET. So we got the ability to write out a new progressive web app, I think it's called, front end, using languages that we already knew inside and out. And while we say it replaces JavaScript, you can actually run it interoperably with JavaScript as well, which is, I think, something else we did. Was it for the Christmas special for Azure Live we did it for, Pete, where we had to use some interop when we built Santa's cognitive services mailroom and that kind of thing?
You've also just proven you've not had enough to drink because you can say interoperability without actually slurping it. So
I had to think about it. I'm not going to lie. So you can also do it with hosted ASP.NET Core with it, or you can use client-side WebAssembly. I think in this instance we are on the server-side end because we haven't gone completely serverless. But again, if you go to Azure Live and you look at our shows there, what you can actually see is our Git Watcher, which is completely serverless and completely client-side in terms of the front end, where we don't actually touch on using any of the .NET Core hosting piece at all until we start looking at our function apps APIs. And it ultimately means that, like I say, we can run .NET client side without any plugins, any hardship that we've probably come across in the past, and it does support most modern browsers as well.
Oh, but Silverlight was so good, wasn't it?
Yes. Now, one of the things that we need to do to be able to support multiple users, even when it was just Pete and I tinkering and that kind of thing, is we needed some way of managing real-time communications. Now, when we're looking at things like Mars rovers and that sort of thing, obviously they're not necessarily going to be using Signaler, but this is the kind of thing that they could be using as an example. And if you wanted to do this sort of stuff at home yourself, it's really great for that real-time comms. So SignalR is great. It's open source. It's another Microsoft library as well, and you can go and see all of how it works through GitHub. But basically, it lets us do that bi-directional real-time comms. So that could be feedback from the robot. It could be a chat app where Pete and I are chatting. I know that on my blog, I've got a WebAssembly and SignalR chat app example that you can take a look at and build out yourself. And it supports lots of different ways of basically passing information across to the UI as well. Now, like I say, we are using the ASP.NET Core hosted version here, but what you can offload all of that SignalR hub stuff to Azure itself by using the actual Azure SignalR service, and allows you to do serverless flavors of it as well, which makes it fundamentally cheaper. So, Pete, the robot firmware. Do you want to bring code up for this? How would you like me to go about it?
What's the next slide? I can't tell.
The next slide is about continuous deployment.
Oh, okay. So we can actually show something. So if you stop presenting and I start presenting, that's probably the best idea, isn't it?
Yep.
Screen 2. So normally I've got, obviously there's two versions of this talk actually. There's the version that I'm doing with Liam today, which is more sort of leaning towards the DevOps side of things and just demoing all the tech. So I'm not going to go into depth about how all of this works, but I will just show you the code and run through the bits. Normally what I would do, in fact, I've given a version of this talk, you can go find it on YouTube. I'd run through all of the bits and I'd be flashing LEDs and showing you how to do all of that. But really that just steals time away from the other cool stuff that we'll be doing. So it's worthwhile I'll show you what the code looks like for those things, but I'm not going to run through in detail how that works. But again, with the GitHub link, I've got a heap of branches in a workshop that you can step through yourself. And I know, John, you've done this already. So the first part of that was just flashing LEDs. So there's not much to this. If I zoom in just a little bit so you can see, and obviously make sure, shout if you can't see, and I'll try and help you out. Also make sure that I can see the chat. Good. So I've brought in this system.device.gpio NuGet package that I mentioned there before. And this is what does all of the heavy lifting of most of what we will be doing. And there's just a little bit more that we'll come to in a bit. But this first demo, flashing LEDs, again, I'm not going to run through this because you've all seen LEDs flash. But it sort of sets the baseline. We create this GPIO controller, and we pass into this board numbering scheme that I mentioned before. So that sort of gives you your control over all the GPIO. And then we make a couple of variables, and then we can open a pin here as an output, and we just pass a pin number in. I've just reused it, so it saves me typing 10. And we open that pin, and then you can use controller.write to write a high or a low value to it. And this one just has a thread.sleep in between setting it on and off, so you get a flashing LED. So that sort of gives you, there's not much to it, but once you've got that far, then you've got control over the GPIO, which is nice. Obviously, one of the next things you're going to want to do is read a button. So there's a little branch for that. There's not much difference in here. Aside from now, I'm opening a button pin, and I'm doing a pin mode of input, and it's input pull-up. Now, you probably don't remember, but on that circuit diagram, the button was connected directly to the Pi. You have to make sure that you pull that button in some direction, otherwise it'll just float there. These are something called open collector inputs. So if you don't tie them in a direction, they'll just float there, and you might be lucky and it'll work, or it won't. So if you do this input pull up, it uses a tiny little inbuilt resistor inside the Pi and pulls it high. And then when you press the button, it then connects down to ground and pulls that input low. So you've got a definite state change between those two on and off. And then down here in this while loop, I'm reading the button, and it seems a bit backwards because of that logic. But when the button reads a false, when that input reads a false, then I set the LED on. And that's because pressing it joins that input to ground, so it takes it low. So it just seems a little bit backwards. And that's all there is to reading inputs there. But that's just a little, just remember to do that. That input pull up, or put your own resistor on there and pull it in a direction, whatever suits, but that's a free resistor, so just use it. Then we step through a bunch of stuff here, and I'm not going to go through all of these steps. I'm actually going to step right back to main and walk through the finished code. So if I go back to main and let this do what it wants, there we go. So what I've added here is this IoT.device. So there's a bunch of device bindings that you can get as a NuGet package. And this is a bunch of somebody else's code that they've written to interface to peripherals. So like servo motors. So you've got PWM control built into the system.device.gpio, but there's all sorts of pulse widths and frequencies and stuff like that you've got to fiddle with to get that to work. And all we want to do is just say, move that servo to 28 degrees and be done with it. So this is one of the bits of that device bindings NuGet package that you get access to. It also gives you access to I/O expanders and temperature humidity sensors, and a great swathe of them. There's probably about 40 different devices, and that keeps growing. That's a really well supported NuGet package. The next thing I brought in here is the SignalR client. So there's two parts to a SignalR story. You get the hub, which lives on some sort of a server somewhere. So the way we're doing it, we're using hosted Blazor client. So it's Blazor WASM, but there's a server backend, and the server backend contains all of the SignalR hub stuff. And that's just a little nexus, and all of these clients connect into that. And then you can write routing code then if you like, but for the most part, we just send out messages that get sent to it back out again. So if you imagine a chat app, this is the hello world of Signal R, if you will. You have a bunch of people connecting into that hub and somebody types and everybody gets that message. And that's what I've deployed here. I've sort of stolen that chat app, which we'll see when we go through the code a little bit more. So we can create this hub connection just here, which is what we'll be doing the Signal R heavy lifting. By the way, I always leave this console right line hello world in all of these projects, because if, like this one, when it starts up, it doesn't do anything until it's told to do something, you don't know if it's worked or not. So this just tells me that it's running. The next thing I do is I create some servo motor control here. So we take this PWM channel that we create here, and we create it with a bunch of stuff. We've got a chip number and a channel number and a frequency. There's only one chip on the Pi for PWM control, and there's only 2 channels, which I'll get to in a second. So that's what these 2 blocks are doing just there. Once you've created your PWM channel, you pass it into the servo motor control, which is part of the device bindings, and you specify the angle. These are 180-degree servos. So you can get 360-degree servos, but if you imagine the up-down part of that, it's going to look quite funny if it's just spinning around and the wires are going to get all tangled, and don't do that. And then there's a minimum and a maximum pulse width that you can fiddle with if it's not quite taking you to the extremes of your servo. That's what they're doing, and this is a frequency up here. This was the demo code, and it just happened to work for me, so kind of just leave it as it is. Next up down here, there's a slightly different PWM channel. As I mentioned, and Liam pointed it out earlier, there's only 2 hardware PWM channels on the Pi. Now, a hardware PWM channel is you just tell it what to do and it does it in the background, completely aside from the rest of the operating system. So it's dead good for really strict timing, which is what you need for servos. So you can create a software PWM channel, but now you're doing that on top of the OS and you're at the behest of the OS. And it's quite complicated, and it took me quite a while actually to get this to work, where I had everything aside from that true when I was doing this before, and it was jerky as hell. And I know, John, when you built yours, you wired all yours up and you got the gripper to use that software PWM, because it didn't matter if it was sort of an on-off control. But I spoke to the people that made it, and they went, you do realize that if you stick a true at the end of that, it puts it in high precision mode and it just works a lot better. And it was definitely one of those Picard GIF moments, because I tried all sorts of things, fettling with these numbers and everything to get it to work. And geez, yeah, it was frustrating. So it wasn't included in any of the workshops that I did for that reason up until recently. So that's that. After that, it's exactly the same. You just feed in that software PWM channel into the servo motor and you control it. I've got slightly different numbers. I doubt it makes any odds. Then you start the servo motors up, and then down here we're connecting to the Signal R hub. Now, one thing to bear in mind over here is that I've had to do this dangerous accept any service certificate, because I'm not very good at security. I'm an IoT person, so we're not supposed to be, are we? So that's what this is for. Now, actually, this came from a moment in time before we had this deployed to Azure. So this was deployed to my PC. This code you're looking at here is on the Pi, running directly on the Pi, building and running. And so it would connect over my internal network to the PC running it, and it would complain about client certificates. So I looked on the internet and did loads of searching around, and they said, oh, you can just reset all your certificates and it should fix that problem, and did it heck. Didn't bother with that. So somebody said, just do that. So I did, and it worked. Oil and water, quite right, Reese McDowell. Yeah, don't do this. It kind of tells you don't do this. But for a demo, it's perfectly fine to do that. And then we've got this automatic reconnect, so that if I stop something or the internet goes down, when it comes back, it's gonna reconnect again, and then we build it. Then here's the stuff that makes the servos move essentially. So this is the messages that we're going to receive from that Signal R hub. If you remember, we can send a message from somewhere else, and that Signal R hub will then just send it out to everybody. And then I've got user and message, which sounds very much like a chat app, doesn't it? So I usurped the user to be the servo that we want to control, and I usurped the message to be the angle. And it was as simple as that. And I've just got this little move to angle routine that I've got down here, and it just does servo.right angle and then angle. Just made it a little bit tidier. So that's all that that particular code does, and then we start that connection up there with start async, and it sits and it waits. So that's the basics of the robot control code. Now the web code, there's not much to that either. It's mostly a brand new Blazor app. Now the version that I'm about to show you isn't the same version that's on Azure. It's practically the same, but we made some modifications. But the idea is the same, albeit. So in here we've just got some. I've used this Map Blazor library. If you do Blazor and you've not found Map Blazor, I'm surprised, but go and check that out. It's a fantastic open source free set of some nice controls. And I wanted sliders, so they had sliders, so I took that, and then we just wire them up with the max and min values and whether or not you want it to automatically update or not and things. And then we've got a little UL down here that we've actually, I think, still got on the Azure version that just lists out the messages that get sent. And then here we've got another hub connection and a list. And then it's very similar here, actually, where we're just building out a connection to that same hub. So this is the client, just the same as the robot's the client. And then I've hooked those sliders up to these properties here. So when we move the slider, it just sends a message with that servo controller name and the position of the slider. So it's not particularly complicated. So that particular code is dead easy. And then you see here we've collapsed this lot. We've got a client and a server and a shared. Actually, we can ignore shared, but that's for shared models and things. Client was where this lives, where the front end lives. Like actually, it's a WebAssembly application, so it'll actually live on your machine. Then the server here has a hubs by convention, and then you've got chat hub, and there's not much to that in mine. Actually, I think the only difference is we got client.others in the Azure one because it made the whole control a little bit easier when multiple people are controlling it. And then there's a bunch of setup that you've got to do in this startup. You've got to add SignalR into your services and then add the chat hub into these endpoints here. So there's loads of tutorials out there for Blazor and SignalR. In fact, I know that Liam has one. So go on his website and you can follow that.
Yep.
I mean, that's the code. I mean, this is actually running on here, but normally I would, as I say, I'd step through all of these step by step, and you'd see this being built up. But I mean, how far along are we? How long have we got for time, Liam?
We've got about 25 minutes ish.
That's fine then. So
do you want me to go through the changes we made to make it multiplayer, I guess?
Yeah, exactly. Yeah. And then you can talk about the Azure stuff, and you can show it, and then we can hook it up and make it move, and we'll do all the demos. Yeah.
Yep. Yeah, that makes sense to me.
Stop sharing.
I've actually, Pete, just for your reference, in case it's about to go horribly wrong, because I realised we missed a step before we came along, is do a small. I made a small code change so that they're listed as servo 1, 2, and 3 rather than what we're going to do to make the change to do the pipeline stuff.
Okay, yeah, it doesn't matter so long as we put it back. It's fine.
We'll find out, won't we? Because it's still running at the minute. But that side. So let me just quickly share my screen here. So screen 1, there we go. So
by the way, Liam, I've started the robot up just so that you're aware, so that we're ready.
So I'll let you know when that's deployed as well, Pete, so you can have just a quick test beforehand.
Yep.
So like people were saying, we've got these servo controls and everything else, but actually what we had written before didn't quite work when we had more than one person connected very well, because one of the things we need to do is actually show everybody where the controls are updated to. So if you're going from 90 degrees to 100 degrees, if everybody all else said 90, then we'd have problems where we could break the robot, and it's not really a true representation of what's going on. So what we've done instead is we've actually switched to this new way of doing it. So we've got a user connection for each person that's going on through our hub connection with SignalR, and on each one we're going through and telling it whether or not it's disabled. So we temporarily disable a control for all the other users except the person using it. And then we tell the UI that something's changed. You need to update those controls. So everything happens in real time. No, there's no page refreshes. There's no anything in that regard. But when in a second when we do it, you'll be able to see that all of those things will update. That means that if I was doing something, we're not going to just break the robot trying to give it too many different commands all at the same time. We're not going to do things like essentially snap it or slap Pete, as much as I'm sure some of us would like to. It doesn't quite work out that way. So yeah, I think that's really the only change we made, because everything else still functions the same. It's really updating those UI pieces, and then again, this breaks down into a set of WebAssembly and everything else. So just quickly on those notes, let's just have a quick look. So that has Pete, that's deployed at the moment with the resetting. So do you want me to quickly show that as well?
That's good. I'm glad it's deployed.
So you see we've got all these servo 1 and 2 and stuff, and you've got the robot arm there. Look, there's Pete's hand right now. And if I move that, then we'll start moving the robot arm.
This is where everybody else starts. Oh, look at that address! I'm going to go to it, and by all means, you can, because I'm going to paste it in the link in the chat. So go ahead and click that, and this is where people tend to make it go in all sorts of funny directions and smash into things. And please be nice to my robot.
And that's it. One thing that we have done, you'll notice that when I was doing stuff, the messages weren't appearing on there because we're not showing what we're doing. We want to see what other people are receiving. But you can see there that we've got server 1, 2, and 3, right? And that doesn't really mean anything except to me and Pete. So what we're going to do is going to make a quick change locally where we're going to name these things better, and then we're going to push that out all through GitHub Actions. Now, let's just quickly take a look at the actions that we're doing. So we have our .NET YAML here. Just close all that so it looks a bit better as well. And it's not a particularly complex way of doing things. What we've got here is we have our checkout of our Git repo. We're setting up .NET for how we want to use it. So we specify what version of the SDK we're going to use, which in this instance is .NET 5. We do a clean on everything, and then we do a .NET restore. So that nothing special is happening here. So even if you're really, you'll be familiar with this already if you build any .NET locally, where we can restore our NuGet dependencies. Then we're going to build it. We create a publish package, and then when we've got that, we're actually using this Azure Web Apps deploy. This Azure Web Apps deploy action, which will take that package and put it into our Azure subscription that we've got now. We aren't doing any infrastructure as code here. We've stood this up by hand, but in a future one, we could probably expand that further so you can see the whole end to end. But we're just saying, here's the app name we're going to deploy to. We've got our publish profile that we've already set up as a secret in GitHub that we can use, and then what package we're deploying as well. So if I go to index.razor, if I remember rightly, servo 1, I think, was rotation.
Yes, and then reach and then grab.
Let's change that.
Oh, of course it's going to do that.
Yeah. And we have reach.
Yeah. Oh, yeah. Okay. 2 of each.
Yeah, because we replaced that with a blocker, I guess. That's the way to phrase it. And then we've got all the grab stuff there as well. So let me just quickly open up the terminal, and we'll do, okay, let's do git add dot git commit -m to friendly labels.
While Liam's doing that, what was really cool is that Cliff Aegis and myself ran this as a workshop for the Microsoft garages globally. It was dead cool. And literally we had all of the garages involved. So Microsoft employees were building these live with us. And at the end, we had several of these robots, and we could control all of them with this one site. So we just tell everybody to point, just like I've done here, point at this particular site for the hub. And as I said, it sends these messages to all the clients. So it would be any robot. So we were able to make them all dance together. It was quite funny, really.
So what you can, well, I didn't realize you did so many all in one go, Pete. That's awesome. That's cool.
Someone's trying to break it now.
What we've got, so my get commit's gone back. It's already triggered based on the triggers that we had before, which is just commits into master or main, sorry. And this is already running. So you can see all of those steps that it's interpreted. We're already done the build, and now we're doing the publish. And in a second, it's going to deploy to Azure. Now, what should happen is it shouldn't particularly interrupt what you guys are doing at the moment because of the line of code that Pete mentioned earlier with the automatic reconnect. So it will force a level of restart. So if we go down here.
Yeah, it's in an Azure app service. So the app service will get closed and restarted when we deploy this code. So there'll be a time when the hub doesn't exist until it starts back up again. So probably about 30 seconds or so of
yeah, it's not long, is it?
Disconnection. No. And Mert's right, Skynet. This is definitely Skynet. I should use this for scratching my back when I can't reach. It's perfect for the bollocks of it. I wouldn't recommend it if you had an itchy eye, though. We're using OBS Ninja, by the way, in the background here for that video feed that you can all see on your BCS sites address there. The reason why that address, by the way, is because that's the first place we demoed it was for BCS. So that's why that's there. And I'm holding my robot down because it comes apart when it goes too far down. So, and then it can damage itself. So that's what I'm doing.
I think it's crashed, Pete. Or at least no, it won't be because I'm updating. There we go. Yep. So if I refresh now.
It could also be that I might need to restart, but I shouldn't do because I've got auto restart on there. Let me stop the code and start it again just in case. So it shouldn't need that to be perfectly fair. And it
might be that I'm just missing that line from mine because I thought I'd merged your PR into it. Here.
It's still working. It's still working. Somebody's moving it anyway. So I'm still connected to something. Oh no, you are doing it. That's right. It's working. I think.
There we go. Yeah. Cool.
So that's cool.
So that's it. That's it. That's you guys controlling it remotely from that URL.
But we have an extra little demo. I spent some time making a VR version of the app. Obviously, as you know, Unity, you can program C# in that, and with a bit of fettling, you can get Signal R into that as well. It did take some fettling actually because I found it quite hard to install npm packages in Unity. But if I switch to my browser, then if I just refresh this page and get rid of this and get everybody back on the screen again because you've all disappeared. There we go. Then I'm going to stick my headset on and obviously make sure that you can see the screen and everything. But if I get this on and then I start casting. Yeah, absolutely. Right, if I start casting here, then hopefully you can see my screen now.
I need to scroll down a little bit.
I don't think it's showing it, is it? Let me just refresh. Let's try that again. It says it's casting. I'll stop casting and do it again. Cast. Computer. Next.
What you might need to do is make it full screen as well, Pete.
This is where this particular demo is not going to work. Hold on a minute. Let me. Yeah, that should be working. It says it's actually casting. You're now showing your headset on another device. So it says I am. That's weird, isn't it?
This is the only bit we didn't plan. Just quickly.
Well, I've tested this before and it's normally fine. So let's try this one more time. Oh. It is casting to it, but the Oculus app is broken for some reason. let me try closing that and doing it again. Be interested to know if anybody's actually done any Unity stuff in the chat.
Other than the bits I've been doing lately, I'm trying to make a racing game in the Azure-ish live theme.
Oh, nice. I like it. Right, let's try again.
I'll distract them quick with other stuff, Pete, whilst you're solving that.
Yeah, I don't know why that's not working. Hold on a minute. Let's try another browser, shall we? We've got many browsers. You know, I tested this a minute ago and it was working, and now, of course, it's not because we're demoing.
Of course. That would be too easy.
It would. Oh, it's going to want me to log in as well, of course. Which is probably not got... Right.
Do you need to close the other one just in case?
I don't think it's open, is it? Oh, no, you're right. It is. At least no one's broken the robot arm yet. That's reasonably impressive.
Now you've said it.
Is there any questions while we're faffing with this? It's broke, look, for some reason.
It could be Oculus.
Yeah, it could be. They're probably having a problem. Let me. I'm going to restart my my headset. Let's have a look.
If we are having problems with this, one thing you can see us do this talk again tomorrow as part of Global Azure as well. I think we're doing it about 1 p.m, aren't we, Pete?
Yeah, I'm wondering if the problem's casting.
Yeah, potentially.
I wonder if it's Teams that's causing that problem more than anything. So I've just stopped sharing for a second, and I should try it again. The URL to control is oh no, not that. Is this? There you go.
It means to control you, Pete.
Yeah. Oh yeah. That's fair then. I see what you mean.
But I mean, like I say, if this has issues this evening, what we'll be doing is we're actually doing this talk tomorrow as part of Global Azure, and you'll be able to see that from about 1 p.m. UK time on twitch.tv/Azure-ish live. You fixed it.
Yeah. So let me try. Let me just make it full screen here. I think it might be trying to share to Teams. I've never tried sharing this to Teams before, so let me try this again. I'll try sharing the window instead, actually.
Yes.
Might help. Right. How's about that? Can you see?
Perfect.
That's good then. So if I go to my apps and then drop this down and unknown sources, then I've got my third Oculus app, quite aptly named. Funnily enough, made in Unity. And there's a robot. So there's a robotics connections type addition to Unity, which is quite new actually, allowing you to do this sort of stuff. But I've got some sliders that I've made there, and you see somebody just moved the arm there, and you can see it moves in the app. So if I move this, there you go.
It's Pete's dead. It's fallen over on the desk.
Oh yeah, well that's what I'm saying about if somebody starts messing around.
I mean, the real test of the Unity end of things is to make it fall over in there as well.
Yeah, that's true. I bet it's fallen over again. It wouldn't surprise me. But
It's
yeah,
still going.
there's the grab as well. But I broke the grab the other day. The grab does actually work in real life, but I changed the angles and I forgot to update the robot. But you can see it move. Somebody was moving the grab there a second ago, and you can see it moving in the app, in the VR just there. Turn it. Oh, yeah. Stop playing with my robot. So yeah, I mean that's the basics of how that. But I mean, what this proves is that you can do this anywhere. Once you've got that connection, then you can control this from anywhere using anything that supports .NET, which is pretty cool. And I just wanted to make a VR app that interfaced with something in the real world as well. And I know David Fowler, one of the creators of SignalR, he retweeted the tweet when I tweeted that out a couple of times. So it's nice to see that the creator of SignalR had spotted what I'd done with it. So yeah, that was pretty cool. Was there any more slides? Was there like?
No, we are at the end, Pete. In fact.
Okay. I will.
So I guess. Does anybody have any questions? I mean, most importantly, thank you to listening for us bang on for the last sort of 55 minutes about stuff that we just had a lot of fun playing with. Really, we just started tinkering one day, and here we are. So
that's where we got to. I'm going to find the link for the GitHub. Here we are. This one, and I'll just paste that in the chat so that you can see. Thank you very much. It's a bit of fun, really, but it shows you some actual practical concepts there that you can go and use. In that GitHub, there's a workshop you can follow through everything, and as I say, I know Johnny, you went through and did that and built one, and even Dockerized it in the end. So there it is. Look, it's slightly more powerful V2 version of the robot I built.
I never thought there would be a point in my life that I'd be on a virtual meetup holding a 3D printed robot arm to 40 people.
I mean, this is, so we've been talking. We talked after last time we did it, and we think we've got a better idea of doing something a bit more involved. We were talking about the possibility of creating a Wi-Fi connected remote control car that you could all control from the browser as well, and maybe have folks try and navigate it through a maze or something like that.
Yeah,
I've not laughed so much in the last couple of comments. I think the comedy value of that alone is brilliant. But no, well, I don't think I need to blow any more smoke your way. I think I do enough of that anyway on social media, guys.
Thank you, John. We love you, though.
I'm sure everybody will agree. I mean, it's just such a fascinating area. I mean, certainly area personally, it's keeping me driving the passion for tech, and it's brilliant to see what the guys have done there with that end-to-end story. And I was quite excited for them to be able to come and show our user group. So thanks, guys. Really do appreciate it.
That's a cool comment from Chris, by the way, before you carry on about, and that's something we've thought about. And I know having recently done the NVIDIA Jetson stuff, the interesting thing about the NVIDIA Jetson Nano is that it's pin-for-pin compatible with the Raspberry Pi. So it's got all the same.
The answer is yes.
So yeah, it is. So this is what Johnny Chips is holding up there. His is connected into a box with a fan on it and everything, but that's what you get inside. But you can do AI at the edge with this. So you can train your models up in the cloud, send them down to the edge device, and then you can do local recognition. So absolutely, we could do something like that. I need to get the job that Johnny was talking about earlier, because work's getting in the way of me having lots of fun at the minute. So I need somebody to pay me to do the fun stuff like this.
I mean, that's the other thing, isn't it, Pete? I mean, we've been talking about loads of ideas around this and how far we can take it, but it's a case of having time. So another idea we had was building a couple, combining the two in terms of the robot arm and the remote control car idea, and kind of doing an interactive robot wars type thing.
And there's me thinking you were going to do a time machine then, the way you were building that up, because you had a lack of time. You were going to build a time machine controlled by a Visio.
Mine is time turner. I just need that. Somebody's already done that. Or, the DeLorean, obviously.
No, again, really appreciate that, guys. I don't know if everybody wants to come up. Obviously, if you've got any questions for both Pete and Liam, then you know where they are. You've got their socials and whatnot. But yeah, let's show our appreciation. Thank you so much, guys. Really appreciate it.
Thank you very much for having us.
Not at all. Anytime.
I'm stopping the servo machine now so that it can have a bit of a break.
Picking up the batteries off the floor, eh, Pete?
Yeah, pretty much.
Right. Well, we're pushing on with time, and we've still got a quiz to go. And of course, we want to give away some of these hoodies and T-shirts. So for those of you that are sticking around for the quiz, and also the feedback link at the end, because you have to do it. What is Dean putting his hand up? No, he's on mute as well. Okay, right. Ahmed, are you there? Are you ready for your screen share?
Hello.
How do you do?
All good. How are you doing?
Yeah. I don't think I've laughed so much at just seeing the comments then in the last part with Pete and Liam.
So I'm getting ready with a screen share. Just a moment.
Do you want me to read out the questions, Ahmed?
Yeah.
Yeah. Actually, this is Anna's quiz, right? So.
Well, I did the quiz. I sent it over to Anna, and Anna's given it to you to present.
Oh, okay. So it's yours then. It's a full circle. Okay. All right. Just a minute. Closing down a few windows. All right. There might be some lobby music.
Do you want to make your text a bit bigger, Ahmed, and maybe
Are we supposed to be doing something here, by the way? Are we supposed to be logging into something?
Yeah, if you've got a Kahoot app, Pete,
I'll have a look.
Got the Kahoot app. Everybody, here we are. There's the URL. Jump on, tap in the pin.
I need to get that app.
If you don't have a device that can get the app, you can use a web browser, but it can be a bit finicky.
Oh, I'm not up for finicky in quizzes. I want to win. Oh, it's 43 meg. Oh, jeez.
43 meg? Really?
43.
What, on the phone?
Yeah.
Wow.
It's all that Bitcoin mining text that's in there, you see.
Yeah, to stop my my miner for this, it was getting a bit warm in the room.
Oh, yeah, fair.
Dean is laughing to himself because he knows what I'm on about. Yeah, Bitcoin mining. Well, it's Ethereum mining. Cool.
I had to rebuild my entire computer based on our chat the other day about Bitcoin mining.
I'm gutted because I knew about Bitcoin, obviously, like a lot of tech people, a long time ago, when it was actually quite easy. You could mine with a Pi quite easily and get Bitcoin. It probably only needed about 3, and then you could retire now.
Yeah, yeah. Well, that's the case now, isn't it? How are we getting on, everybody? Any more? I mean, we've got about 30 people in the chat.
What account type am I doing? Personal?
Yeah.
I guess so. Oh, I got 1,000. I got a bloody type a load of stuff in now, including your age.
Does Ahmed know he's doing his work on our quiz? Ahmed?
Does that work, is it?
Well,
I'm just muting myself because of the horrible music. Oh,
we can't hear the music.
I just saw that.
Yeah,
I'm screen sharing my work.
Yeah, I see you're doing your work on top of
that. Looked cool. That said mesh. I like that.
I'm debugging my dev container. Had some issues with it. So, anyway.
Right, I think I'm ready.
Right, we all ready?
Any more? You in, Pete?
There I am. If I didn't sign in like that, no one would know who I was. Just like you, Johnny.
Well, I tend to sign in dependent on how difficult I think the quiz is going to be, either with a pseudonym, or if I think I'm going to come pretty well, I'll take the glory.
What name have you gone for today, John?
I'm not on it today because obviously I know the questions. So
Gary.
Right, if you're struggling to get on, send us a message. Otherwise, we will assume everybody is good. Is everybody okay? Yeah, a few people got to go. Cool. So, right, what we're playing for then is first prize is a £25 Amazon voucher and a Welsh Azure User Group hoodie and some stickers. Second prize, we'll get a T-shirt and stickers. Don't forget the tweet and win, or LinkedIn and win. Please post on LinkedIn as well if you don't use Twitter. And we'll have that second £25 voucher for those that stick right to the very end of this and give us some feedback with the feedback link. Cool. Let's make a start then, eh? What I'll do, I'll read out the questions. Well, we'll see how we go. I'll just read out the questions. Everybody ready?
All right.
And we're off. Question number 1. What is the primary use of Azure CDN? And for those that haven't used Kahoot before, the faster you answer the question, the more points you get. So if you know the answer, answer it quickly. If you don't know the answer, guess.
That fourth answer there is almost right, which is why somebody's actually answered that one, but even so.
Yeah, no, absolutely. I think the question actually, Pete, was what is the primary use, I guess. In being really pedantic there.
No, I agree.
No, yeah, absolutely. Well, everybody got it bar one. Who was that you, Pete? Were you the one?
No, apparently I'm on the podium, it says.
Right, next then. Let's see. Most people got that. Oh, Pete. Straight in there. You played these before, have you? Right, next question. Which of these components is the odd one out when configuring Azure IoT Edge devices? Edge runtime, Edge modules, IoT hub, or app service?
Very good.
Cool. Majority of people got that. Obviously, app services not necessarily affiliated with anything to do with the Edge.
It didn't have IoT in the name. That's why I went for it.
Well, that kind of gave it away as well. Right. What is TensorFlow? By the way, can anybody guess who wrote these first few questions?
You.
Cool. Yeah. Most people got that. It's an open source end-to-end machine learning platform. Pete is desperate for this one. But it's very close. There's
just want the hoodie.
In it. Microsoft Azure was once known as Windows Azure. When was it renamed?
I've got that one wrong. I don't know. Definitely not those last two. I wouldn't have thought, but I'll probably get it wrong.
Well, it was March 2014, and it was verified on their website. And I thought, you've got to throw a few of these curveball ones in there, haven't you, to kind of, sort the wheat from the chaff and all that. Okie dokie. Next question.
Look where I've gone now. It's terrible. That is.
And Dean's going for it. It's very close though. True or false? Kubernetes is currently at v1.21. There we go. It's released very recently. Hugh is taking the lead.
Oh, Hugh. Jeez.
This. Which of the following is not a valid HTTP verb? Post options, head, commit.
Oh. I don't know.
I went wrong.
I chose correctly. Woohoo!
That's normally what I do in quizzes.
I guess.
Question. Correct. Complete the song lyric. Hey there, wait, Mr. Postman.
Until status 200 is returned. I like that one.
Oh, a moment. Oh.
Tricky.
Oh, Hugh still taking the lead there. According to RFC 232.
Oh, come on.
Status 418 mean.
I go for very forbidden. I don't think it is, though. I think it's not found in this universe.
Oh, dear.
Oh, I'm a teapot, is it?
Everybody's reaching for Google at the moment rather than... I did check it. Well done, Matt, for that question.
I'm way behind now.
I hate RFCs.
According to the 1946-81 movie, what does Postman always do?
Switch to the VSCode.
I like it. Oh, Hugh is.
I can't read these. Hang on, you'll have to read it yourself.
Oh, crikey.
Oh, God. Sorry. I'll have to...
Are we all right?
Oh, what a nice guess that was.
Oh, right. Okay.
I'm taking over from John here.
You are, yeah. I'm okay, right. What is the most popular TV series on Netflix?
Oh, no. Damn it. Oh, really?
Oh, really? One person got that one?
You're kidding me.
Anna did send me the stats, apparently, but I've not got them open to read them, but she did.
So bad, it's good.
Wow, okay.
What language is the word Kubernetes?
Yes.
Greek it is. Yeah, majority of people got that one right. Well done. We're nearing the end of this. Damon S is it's still quite close, mind. Question 13. What nut is in the middle of a Ferrero Rocher?
A peanut. I'll be disappointed with that. What's wrong with it? It's the Aldi ones.
Oh dear. So Damon is. Oh, it's very close between Damon and Hugh. And Pete, you're still in it, I think.
Not really.
Last couple of questions. Cron jobs in Kubernetes runs in.
Geez, I don't know. Guess. Oh no. Server NTP settings, really?
Just 1 second. Taking this here.
Thank you. Checking.
Work
Any change? There's no change at the top. No change.
So no change.
Last question. What does IPA stand for? And here we go. Ready for the drum roll.
I wouldn't mind some Indonesia pale alcohol though, but it sounds quite nice.
That's from Aldi as well, I think.
Yeah.
Oh, there we go. From Aldi. Right, let's see who got the win. So, third place, well done to Pete Coates. Good scores. Second place, winning some stickers. Well done, Hugh. And our winner is Damon S. Well done, Damon. £25 voucher, hoodie, and some stickers. Right, so Damon and Hugh, do me a favour, and I don't know if you follow me on LinkedIn or Twitter or the group. Message me in one of those platforms, or speak now if you are. Are you available to speak? So I'm obviously going to need your addresses to send out your prizes and obviously get the sizes off you. So reach out to me on one of those mediums, and I'll get that sorted. Right, thank you everybody for taking part in that quiz. That was and sorry for my minor. Who came fourth? Was it at the bottom? I think it was at the bottom, wasn't it? Who came fourth?
Yeah, I can't see now. View full report will tell you, look, don't it?
Yeah.
If anyone wants,
we don't need to see the full report. I don't need to know how bad I did.
Right, now, as Dean was saying earlier, we've got to sort of kick off the end of the show, in true sort of kicking off the end of the show fashion, as the music doesn't come through. Right, okay. Can everybody hear that? I'd like to have a bit of music to leave us.
Yeah, I can hear it.
All good. Right, everybody, thank you so much for joining. Don't forget to join in on that tweet and win, and LinkedIn and win. Win yourself. We'll pick another winner tomorrow out of all the fun. Is it my screen flicker or is it just me? My voice. Right, yeah, no, like I say, thanks for joining. Really good fun. Thank you so much to all our speakers. Absolutely fantastic lightning talks we had. Pete and Liam, thank you so much for that. Really enjoyable. And sorry to everyone for losing it there. Next month, we have a virtual Azure data center tour and a few more lightning talks from the amazing Peter Tenzer and Wim Matheson. So we're going to kick off with Peter and Wim, do those lightning talks. We're going to look at it's the container alphabet soup, as Peter has called it, and we got Wim come to talk to us about Azure Applied. So we've got in-house cloud consultants, and of course our future event is data center, Azure data center. So please, that will be announced now within the next 5 minutes on Meetup. Join, go on the link RSVP, and of course I'll be back to that next. And there we go. There's our feedback. You can scan the QR code or go to the URL. Leave us some feedback. Be critical, be thankful, whatever you want to be. Tell us how you felt about this. And join us for the next group. Meetup. Thanks everybody for joining, and we will see you all next month.
Thanks everyone.
Really cheap.
Thanks, guys. Take care.
Thank you very much. That was good fun. I was just sticking around for the music.
That's all I do.
as well my Amiga demo deck is that.
So, at what point do you stop the recording, John? Out of interest, is it just before someone talks